welcome to the Authlete channel. I'm Domingos Creado and this is the OAuth track, where we talk about the specifications on the OAuth space. Today we're going to finish the review of the OAuth specification that was published 9 years back. So we're going to do it with covering the security aspect of it. So as a living document, the working group keeps a document called Security Best Practices. So still today, 9 years after publication, you still see updates on that document, and there's still discussion on the working group mail list. So it's a living thing, and we're going to keep brief, covering what they already noticed at that time when it was published, plus some organization perspective that I can bring from my experience on this industry. So if you want to keep we're ain't gonna cover here the client credential. So if you want to know more about it, check out the card, right? There's a previous video on that where we show up the security aspect of it, how that works, and the security aspect of it. So without further ado, let's get started. So as usual, the security has many layers, but none of the layers has too much fancy topic on it. You might see some of those are more technical. You're going to see more the technical discussion by the end of the video. But first, I'm going to cover the most impactful one that are related to the organization part, right? So first, we need to get a clear view and clearly state that the OAuth is a user-centric, which means that the authorization server relies on the user to consent permissions to a client, and here we need to stress out that it's on the consent of the user that makes a lot of difference, because the sanity of the authorization request, everyone can fool it, right? So, and whatever there's a person, there's an unconscious error that might happen, or a misjudge, or a social engineer might happen, and stuff like that, right? So that's one of the hardest part. And there are three vectors related to the user behavior, right? One is the complexity of the scope. That's mainly part of the API provider to work on it. The second part is related to the user behavior, that you can educate it, the user, or you can make it aware of more stuff. And the third part is the deceiving client, that the external attackers might want to use the AS as a vector attack for the customers. So the first is let's take a look on the complexity of the scopes. So the scope itself represented a permission, and it might be coarse grain or fine grain, and there's a lot of difference when you're talking about the grain size, right? So let's say those three lines are examples that I've picked from my experience. So if you look at the first one, it's a very coarse grain where the user is granting the read-only part as well as managing the files to a client. So it might happen that the user might want to only allow a client to read only, but here he's also granting permissions for the client to delete files, to create directories, to delete the entire directories and stuff like that, right? And change the files that the user might have wanted. So you see the course of the grain here, the permissions is too coarse grain, as well as the same here on the second example. For instance, the view and manage your mail. Does it also comprehend setting forward rules for the new mails? Those kind of things that it's really difficult for user to realize the full extent of it. And the third one, it's a kind of, you see some split, the course is getting finer, but still a lot of stuff happening here. For instance, the read consumer, for instance, you're allowing a client to read all the attributes of the customer, even the social security number or the passport number or whatever sensible data you have stored on the database of the identity. It might happen that also the write consumers, you're allowing it to write any attributes at all, or you're kind of relying on a second factor for authorization, which make really difficult for the APIs to deal with that, right? So those are the things that the API provider can better work on it. And rather than having a very simplified version of the permissions, to simplify the consent collection from the user, you can also make some a better segregation and distribution of the scopes and the permissions in order to prevent the user from granting too much permissions to clients, right? So this is a second. There are two related to more on the administration part of the domain. So one is related to those new kind of tools that are getting using more and more for preventing data exfiltration. In other words, data that's getting exported by is getting out of the door for someone that is attacking, or right, and it might happen in different ways, right? So it can be throughout REST calls or mails that are getting through and stuff like that. So you see more and more tools that are getting deployed that relies on permissions to process sensitive data, like mailbox scanners or monitoring tools and stuff like that. Those are very hard to restrain the permission on it, and it's very difficult. So it might make a lot of sense to better segregate what can be scanned, what cannot, what stuff like that. So another related scopes issue that I see often is that sometimes the permission is too broad, right, for granny, like configuring the federation, right? And where you're allowing a client to enter as an administration or full administration power to change and including new entities on the cycle thrust, or deleting or including new keys to your federation, and that can hit really hard if someone hack it. Or for instance, configure directories of users, including new users, configuring instances, virtual machine instances, network rules for forwarding content, stuff like that. And with the previous one, everything that can be used for persistent access can be really hard and really critical, and be very clear on what is getting collected. So, and regarding this topic, there's the major recent attacks that you see on the cloud. It's usually caused by user administrators granting too much permissions to clients, like for instance SolarWinds, right, where the attacker was able to was granted access to chain the federation, and was able to include new federation entities into the cycle of thrust, and creating a persistent access to the cloud. Right? The example that I'm showing you before, where the customer will grant access to a client to access his files, as well as changing it and also deleting it, right? So the user might not read it properly, or might not understand that when we're talking about managing, we're also talking about administration functions that he might not want to or willing to grant it. So another aspect of it is that the user might think of and does not fully understand that he don't have the proper knowledge of what's the client intention, right? So, which means that he might not be able to fully realize the risk of granting access to a client to his protected resource. So he might, or the customer might play down or reduce, understand the risk is very low, and might that create a attack vector for clients on the protected resource. One other aspect of it that you see more often is that the client thinks that if the client is able to ask his permission, the authorization server has done a proper security review on the client, right? Which is the hardest one to do it. You see more and more marketplaces implement those kind of things, but usually they can't do a full review across it. Usually the AS implements a sort of two tiers of program, but the client, the customer might not realize that there's a difference on what is getting scanned, what is not, what is verified, what is not, right? The customer might blame the authorization server for the misbehavior, right? Which is something that's really hard for addressing. So one suggestion that we do it for customers is when implementing authorization server, it's always be very explicit on what is getting requested to the customers. Some restrictions, like for instance, the Australia open banking now requires the collection of consent to be very explicit. Same holds for different ecosystems, right, of open banking. We also suggest customers when deploying authorization server to split and implement a kind of segregation of permissions, preventing the clients to have full permissions or take over the entire account. Right? That's one of the aspects. Another part of it is more related to social engineers, related to deceiving clients, right? So where an attacker can deceive and disguise his identity behind graphics or names and stuff like that are very similar to older clients, and the customer might not realize that he's granting permissions to the wrong client, right? So that's why we also should suggest to deployers to implement a workflow verification steps where they can check the authorization servers before the client can use it, to first check for similarities and stuff like that, preventing an attacker to use it. That also needs to take place when the client data is also changing, right? Another very common error is around taking a public client as a confidential. So let's first review what is the client, a public client and a confidential client, right? So confidential clients are clients that have a credential assigned to it that can be established. So which means that the authorization server can authenticate it. A public client don't have such a credential. So as an example, single page apps, or native apps or mobile apps, those can't be shipped and sent to the customer to run it securely with a credential assigned to it. So the error is usually take one of the public client and take it as a confidential because of some fancy obfuscation mechanism was created, or because of who developed the app itself, and those kind of things. On top of that, usually the authorization server never asks for explicitly consentment of the customer, which means that there's a public client that can trigger an authorization process that will, as soon as the user has logged in, the client will get every permissions that he asked for on the authorization server. So there's the security problem here is there's too much trust assigned to an instance that can't be checked at all, right? So there's some customers that notice this problem, try to implement a kind of client validation. Usually they are kind of missing some aspect of it, which is rely on the process of creating a credential to that client, right? Engaging the customer in a process of registering the instance and then creating a credential specific for that, which then turns that instance a confidential client rather than a public, which can be really effective. So, and this can rely on dynamic client registration specification that it's available today. I'm going to cover this specification later this year. So now we're going to start drilling down the more technical ones, security aspect of OAuth. So the first is around the authorization request and code flow. So if you look at again for this this flow, if you haven't seen, check out the card again. This is the authorization code flow sequence diagram, and here you can see that the authorization request goes through the browser, and the authorization code gets back to the client via browser as well. So everything goes through the browser, and that it's a point of where the attacker can try to take advantage of. So the first one is that usually what you see on the security on more secure ecosystem is that you need to prevent the authorization request to be disclosed to the browser or to be tamper evident, right? By tamper evident is when it's the mechanism where whenever anything has changed, the authorization server can detect that it was changed, right? That's the idea of the tamper evident. So there are some approaches that you see rising. The three different specifications. The first one is a push authorization request that allows the authorization request to be sent without the browser, without going through the browser. And there was the second one. The second way of handling it is using request object or JWT authorization request, where the client can pack the authorization request in a JSON format, sign it, and send it to the client, or optionally encrypt it. And the authorization server can, when receiving it, can check if the content of it was tampered or changed, and if the source matches, right? So it can be easy if using encryption, right? If using encryption, it can be checked if who sent the authorization request. So another aspect of the round robin process of the authorization part is related to protecting the authorization code. So the authorization code gets sent back to the browser by the authorization server, and that process, an attacker might sneak into the authorization code, and there's if it's running as a public client, the attacker now can fetch an access token in the name of the client. One solution that was brought up some years back was the PXE, or proof of key for code exchange. That's a mechanism where a soft is implemented, and even though an attacker might intercept an authorization code, it can't fetch a token from the token endpoint, even though the client is a public, which is really nice. That's one that we should. First one, when we're going back to the authorization process, we're going to look at it. Okay, so this is more a classic security issue. So open redirector is when the authorization server trusts the redirector AI that comes from the first request and send the authorization code on the step number 3 with authorization code on it, without checking if it should allow that or not. So to cope with that, the suggestion is always implement it on server side and require the client to provision the redirector AIs that will be used for. So that's how the authorization server can check if the request on the first step has a redirector route that can be used, and therefore redirect on the 3 with a valid endpoint, to a valid endpoint. So one of the caveats here is, as the authorization server will have a database with all the redirector AIs that can be used, one caveat here is how this comparison will be done, right? So today we are moving towards having more and more strict rules on why we're comparing it. So if you look at the FAPI as well as the OAuth 2.1, all of them requires the redirector AI to be compared in full, which means that the client cannot insert any dynamic attribute on the redirect URI, and in order to run the authorization code flow. So that's also this is a security aspect that affects the client part, right? So if you look at again for the same flow, you see that the client will start in a GET request and will receive back in a GET request, which means that as it is a GET request on the third one, it allows a third party to attack it using CSR or cross-site reference. And the way that the client can prevent it, the attack, is using the state. So here in example, the client can attach to the request and the state equals to XYZ. Send it when we're receiving back the authorization code. We receive also the state equals to XYZ. That allow it to compare and contrast and check, realize if the request is spoofing or not, right? So if you look at the WASP top 10, one of the major topics is the cross-site. And there's also a suggestion for two different approaches for resolving it. The first one is using a double submit cookie, where the client, where the website protects itself by sending the same value on the form as well as a cookie. So when we receive it back, it can reason about it. The second approach is using a synchronizer, where the value, random value, is stored on the session side, on the server side, send it as as part of the request, and receive it back, and then the server can make sure that the value that it receives matches with the session. So, and the state parameter can be used in both scenarios. As a double cookie submit, the state parameter can be the same value can be sent as a state as well as on the cookie. One caveat here is that the size of the URL is sufficiently large, but yeah, you need to make sure that it fits onto 2K, right? There's a lot of it, but sometimes, depending upon what you're serializing here, it might not be worth. One other aspect of it is that the size of the URL, as the state is sent on the URL, the outermost layers of the API gateway that you're using might not accept it, right? So that's something to consider. So one other aspect is if you're using a synchronizer token, yeah, the states will be sufficient. And you also make sure that the random value fits into the 2K scenario. Right? Okay. One other security concern is around the bear token. Probably this is one of the most. Today is probably the one where the most of the discussion is happening on that related to OAuth. The client will send the token to the resource server. The resource server will grab the token and assume that whoever sent it has the permission to do so. It's the willful, it's the owner of it, has the possession of the token. So, which means that if anyone grabbed the access token, now he have access to the resource server without incurring into the whole process of authorization that we just described in the last 5 videos, right? So the access token is sent, so back and forth. So that's one of the key issues here, right? Because it can be on the transport, it can be exposed. So there's we need to make sure that we have the proper forward secrecy on the TLS tunnel that connecting the client and the resource server. There's also a lot of discussion. Okay, what is the minimal protocol that we can implement between the client and the resource server to better protect it, right? And there's one in place already, which is called the MTLS, which allows the access token to stamp on the access token the part of the TLS certificate on it. So the resource server now can check if the TLS tunnel matches with the access token. Another one is the Depop, which is getting discussed, and there's another protocol that will be probably established without relying on the TLS. Right. And the refresh token also suffers from the same issue. If you haven't seen the refresh token, please do so. And video. If you haven't seen the refresh grant type video, please do so. And where we're showing you that as the refresh token is a long living, the transport is something that we make sure that it's secure, and also allows you to do the same approach as the access token, where you can use the MTLS or Depop on top of that. Okay, so with that, we close the OAuth review, and probably the upcoming videos we're going to be around more advanced topics. And first, we're going to clear out, take in front of us as the dynamic client registration, as well as the dynamic configuration of the client part, where the client can pull metadata off the authorization server to configure itself. So check out the next video. So if you don't want to lose any content, please subscribe to the channel. And if you like this video, don't forget the thumbs up. And if you want more, any other specific topic to be covered here, just bump us on the sales@authlete.com, and I'll gladly respond to you and include it here. Thank you very much, and see you around.